Hello, my dear students. Welcome back to my channel RK Study Circle IIT. I am Rajkumar. Today, in this video session, I am going to talk about the concept of foot and image of a point with respect to the straight line. This particular concept belongs to the straight line chapter, which is primarily useful for Telangana and Andhra Pradesh intermediate students, which will be useful for their intermediate examination. So when it comes to the straight lines, we are going to deal with the particular chapters. Sorry, we're going to deal with the questions are like the questions from the straight lines are going to be questions on foot and image, foot and image, foot in the sense foot of perpendicular of a point, and questions on ortho center ortho-center. The same time, questions on circumcenter. Circumcenter. So these are the three type of questions what you people are going to face in your intermediate public examination. And let me go with the concept of foot of perpendicular and image first of all. So when it comes to the concept of image, let me represent it's a question number one. And here's the question: if h comma k is the image of a point P of x comma x1 comma y1 with respect to the straight line ax plus by plus c equals to 0, then prove that h minus x1 divided by a equals to k minus y1 divided by b equals to minus 2 times of ax1 plus by1 plus c divided by a square plus b square. And additional question is mentioned here, and the image of 1 comma minus 2 with respect to the straight line 2x minus 3y plus 5 equals to 0. So when it comes to the image of a point, with respect to the straight line, let me mention a straight line which is acting like a mirror. Let me write it as ax plus by plus c equals to 0 is a straight line, and we are supposed to find out the image of p of x1 comma y1 with respect to the straight line ax plus by plus c equals to 0. And let's say the position of image is given by h comma k. So this is the line joining PQ. I can say this is the line joining PQ. Here we are going to deal with the two conditions. The condition number one is line joining PQ is perpendicular to x plus by plus c equals to 0, and the line joining PQ is passes through the midpoint of PQ. Sorry, ax plus by plus c equals to 0 is passing through the midpoint of uh, PQ. Let me explain you how it is. So first of all, let p of x1 comma y1 be the position of image, or let's say object, position of object, and q of h comma k is the image of p of x1 comma y1 with respect to straight line ax plus by plus c equals to 0. Then we are supposed to go with the two condition. Let me mention condition number one. Line joining PQ is perpendicular to ax plus by plus c equals to 0. Then if m1 is representing the slope of line joining PQ and m2 is representing the slope of x plus by plus c equals to 0, then when there is a condition of perpendicularity, the product of slopes must be equals to -1. So m1 into m2 equals to -1, where m1 is the slope of line joining PQ. So I have written P is a point P of x1 comma y1 and Q is a point h comma k. What is the slope of this value? I can write it as k minus y1 divided by h minus x1 into the slope of the straight line ax plus by plus c equals to 0 is given by minus a by b. A by b. It is equals to minus 1. So minus minus gets cancelled. Upon cross multiplication, I will get like k minus y1 divided by b into a divided by h minus x1. Let's say it is equals to 1. And upon cross multiplication, I will get it like h minus x1 divided by a equals to k minus y1 divided by b equals to 1. Equals to, no, not equals to 1, simply h minus x1 divided by a equals to k minus y1 divided by b. So since these two are equal, let me take a third parameter lambda. Third parameter lambda. Let's say it is equation number 1. Equation number 1. So I have completed the condition number 1, which was the line joining PQ is perpendicular to the straight line x plus by plus equals to 0. And the condition number 2 is, and the condition 2 is line joining, sorry, M is the midpoint of, M is the midpoint of PQ, which is given by M equals to H plus X1 divided by 2 and K plus Y1 divided by 2. So X and Y coordinate of point M is given in this way. And one more important thing, AX plus BY plus C equals to 0 is passing through M, passing through through M, point M. So it has to satisfy the straight line equation must satisfy the point M, right? So I can write it as A into x coordinate of point M is H plus x1 divided by 2 plus B into the y coordinate of point M is given by K plus y1 divided by 2 plus C equals to 0. And upon cross multiplication or without cross multiplication also, first we will define what are the values h comma k. So from equation number 1, from here is the equation number 1, I can write it like h value I can take it as a lambda plus x1 and k value I can write it as b lambda plus y1, b lambda plus y1. So substitute these two values in the equation number 2. Substitute these two values in the equation number 2, then the equation comes out to be a into h value is a lambda plus x1 divided by 2 plus b into k value is given by b lambda plus y1 whole divided by 2 plus c equals to 0. C equals to 0. So the total equation comes out to be a square lambda plus 2 times of a x1 plus x1 2x1. Next b square lambda plus 2b y1 plus 2c equals to 0. Upon cross multiplication or LCM, I can write 2c equals to 0. So lambda is taken common outside, a square plus b square is common, and upon right hand side I can take minus 2 as a common, ax1 plus by1 plus c. So the value of lambda comes out to be minus 2 times of ax1 plus by1 plus c whole divided by a square plus b square. Let me write, this is equation number 3. Let me write, this is equation number 3. So from condition number 1 I have developed equation number 1, and from condition number 2 I have developed equation number 3. So the value of lambda we will input in equation number 1 such that from equation 1 and 3, from equation 1 and 3 I can write it like h minus x1 divided by a equals to k minus y1 divided by b equals to the value of lambda. equals to lambda, right? And the value of lambda is to be written from here. So that value comes out to be, the value comes out to be minus 2 times of ax1 plus by1 plus c whole divided by a square plus b square, a square plus b square. So this is the total condition or the formula you can say to find out the foot image of a p of x1 comma y1 with respect to straight line x plus by plus c equals to 0. So here the extension question is mentioned. The question mentioned was, what was the question? Let's go through it. So we are supposed to find the image of 1 comma minus 2 with respect to the straight line 2x minus 3y plus 5 equals to 0. The point is given 1 comma minus 2 and 2x minus 3y plus 5 equals to 0 is the straight line equation. So the x1 comma y1 values are given by 1 comma minus 2. Let me say this one is point P, here is also point P. X1 comma y1 is 1 comma minus 2 and a value of A equals to 2, value of B equals to minus 3 and value of C equals to 5. So upon writing in the above equation, I can write h minus x1 divided by A equals to k minus y1 divided by B equals to minus 2 times of A x1 plus B y1 plus C divided by a square plus b square. This is the equation, right, to find out h comma k. So the value h minus x1 value is 1 divided by a value is 2 and k minus or minus plus 2 divided by minus 3, that equals to minus 2 times of 2 into 1 2 into 1 plus minus 3 into minus 2 plus 5 whole divided by a square plus b square, that is a square plus minus 3k square. So I can write h minus 1 divided by 2 equals to k plus 2, divided by minus 3 is equals to minus 2 into the value comes out to be 2 plus 6 plus 5, 2 plus 6 plus 5 whole divided by the value is 4 plus 9, it is 13. So here the value minus 2 into 3 plus 2 plus 6 equals to 8 plus 5 equals to 13. 13 divided by 13. These two cancel out and h minus 1 divided by 2 plus equals to k plus 2 divided by minus 3 and the value comes out to be h value is minus 2 into 2 plus 1 and the y value k value comes out to be k equals to minus 2 into minus 3 minus 2. Right, so h value will be minus 4 plus 1 minus 3 and the value of k is plus 6 minus 2, it is 4. So the point h comma k, the position of image comes out to be h comma k is minus 3 comma minus 3 comma plus 4 and what you're supposed to write the conclusion, the last step is conclusion. Therefore required not the solution, image of 1 comma minus 2 with respect to 2x minus 3y plus 5 equals to 0 was obtained to be minus 3 comma 4. So this is the conclusion what you're supposed to write. So this is all about the derivation of image of a point with respect to the straight line. Let me go with the second one, that is foot of perpendicular on the straight line with respect to p of x1 comma y1. So here's the question. Let's go with this question once. So here is the second question, which shows like if q of h comma k is the foot of perpendicular from point P of x1 comma y1 on the line ax plus by plus c equals to 0, then we are supposed to prove that h minus x1 divided by a equals to k minus y1 divided by b equals to minus 1. It is simply minus 1 into ax1 plus by1 plus c divided by a square plus b square. So also find out, an extension question is mentioned. Also find out the foot of perpendicular from minus 1 comma 3 on the line 5x minus 8 minus y minus 18 equals to 0. So uh, here is the question how it goes like. So ax plus by plus c equals to 0. Let's say this is the equation of straight line, and for this equation of straight line we have the point p of x1 comma y1, for which we are supposed to find out the foot of perpendicular. Let's say q of h comma k. Q of h comma k is the foot of perpendicular of x1 comma y1 on the straight line. So here also the concept of both the foot of perpendicular and the image comes out to be the same. At the same time, all the steps are followed to be the same. The one and only change is here you're having the position of a object, and here you are having the position of image in the previous concept. And for this concept, the foot of perpendicular is on the straight line ax plus by plus c equals to 0. That's the only difference. Apart from that, everything is same. So I can write, when it comes to the condition number 1, the line joining PQ is perpendicular to x plus by plus c equals to 0. And for that, let's say M1 is the uh, slope of the line joining PQ, and M2 is the slope of the x plus by plus c equals to 0. When two straight lines are perpendicular to each other, the product of their slopes must be equals to minus 1. At the same time, I'm writing the condition of perpendicularity, that is k minus y1 divided by h minus x1, the same what we have written last time. The same time into the slope of the straight line comes out to be minus a divided by b, and it is equals to minus 1 as we mentioned in the top. So k minus y1 into a k minus y1 divided by b into a divided by h minus x1 equals to 1. And upon cross multiplication, I can write it as h minus x1 divided by a equals to k minus y1 divided by b equals to lambda. The same thing what we have mentioned last time. And from here, I can, let's say this is the equation number 1. Let's say this is the equation number 1. And I can write h equals to a lambda plus x1, and k equals to b lambda plus y1. So when it comes to the condition number 2, the point h comma k is lying on the ax plus by plus c equals to 0, the straight line. So it has to satisfy the straight line equation. The point P has to satisfy the straight line equation, that is h plus bk plus c equals to 0, from the equation number 1. From the equation number 1, here I can write h and k values as a into a lambda plus x1 plus b into b lambda plus y1 plus c equals to 0. So from here I'm taking lambda taken common outside, a into a square plus b into b square, and all ax1 plus by1 plus c is written on one side, and I can write from this equation lambda value comes out to be minus of ax1 plus by1 plus c whole divided by a square plus b square. Let's say this is the equation number 3. This is the equation number 3. So from equation number 1 and equation number 3, I can write it like the value of lambda is to be written this one, right? So h minus x1 divided by a equals to k minus y1 divided by b equals to, the value of lambda is this one, minus of ax1 plus by1 plus c divided by a square plus b square. So this is the condition. This is the condition, or which is required to find out the photo perpendicular of a point p of x1 comma y1 with respect to the straight line. So in the from the above equation, I can write a, b, c are obviously the constant values. X1 comma y1 are the position of a object or the position of a point x1 comma y1. It is already known within the question. It will be given, and the one and only unknowns are h comma k, and where the h comma k are said to be the foot of perpendicular of p of x1 comma y1. And the extension question was mentioned like, if p of x1 p of minus 1 comma 3 is mentioned is the point, and what will be the and 5x minus 5 minus 18 equals to 0 is the equation of straight line, then what is the foot of perpendicular h comma k with respect to these two conditions? So I can mention p of x1 comma y1 r minus 1 comma 3, and the value of a is 5, b equals to minus 1, and c equals to minus 18. So upon writing in this equation, upon substituting in the condition of foot of perpendicular, I can get the value h minus of minus plus 1 divided by 5 equals to k minus 3 divided by minus 1, and minus times of ax1 plus by1 plus c equals to plus c whole divided by a square plus b square. Values are these one. So I can write it as like the numerator comes out to be the 26 and denominator is also 26. Both of them cancel out each other and I will get a minus of minus plus 1. So from term 1 and term 3, term 1, term 3, or term 1 and term 3, I can write this equation, and term 2 and term 3, I can write down the next equation. That is upon which the value of foot of perpendicular comes out to be h value is 4 and k value comes out to be the 2. So 4 comma 2, the required foot of perpendicular of minus 1 comma 3 with respect to the straight line was found out to be 4 comma 2. By this we had completed the session for today, and in this session what we have gone through is the foot of perpendicular, concept of foot of perpendicular, and concept of image of a point with respect to the straight lines, and we have discussed the particular examples also. So we will see rest of the questions based on the orthocenter and the circumcenter in future.